Okay, well, good afternoon, everybody, and welcome to this the final parallel session of the day. This is a panel discussion on the future of network monitoring. It will have an interactive format where each of the panelists will make a short presentation on their various viewpoints, and then we'll follow this with a wider discussion. This is very much intended to be an interactive session, and so the audience is encouraged to ask questions. But if you do, please wait for the microphone, because we're streaming this session, and we'd like the remote participants to be able to follow the discussions as well. The discussions will focus on the challenges faced in the field of network monitoring in the next 2 years. The growth of the internet has led to increasing complexity, and this has come with a number of associated security issues, which has meant that network monitoring assumes more and more importance. But equally, it's becoming more and more difficult as network speeds become faster. At the same time, there are concerns about user privacy and commercial confidentiality that need to be addressed. And these are some of the things that the panel will be touching upon. Okay, before we begin now, I would like to introduce each of the panelists, starting with the first speaker. Is Gianluca Iannacone, which I hope I've pronounced correctly, from Intel Research. He received his PhD in 2002 from the University of Pisa, actually before he received his PhD, he joined the Sprint Advanced Technology Labs, where he worked in the IP research group on network performance measurements. Then in September 2003 he joined Intel Research, based in Cambridge in the UK, and his research interests include network forensics, network performance evaluation, and network measurement. Then we have Stuart Parham from Cisco. He worked for a number of years as a network engineer for British Telecom International, primarily working on long-distance telephony systems. He then moved to Cisco, where he now specialises in network management systems for large enterprise and service provider customers. The next person along is Nicholas Seymour, working for Dante. Nicholas graduated from the University of Liège with a MA in Computer Science Engineering, and he's now working for the Network Engineering and Planning team at Dante. He's currently playing a key role to coordinate and ensure the interoperability of European performance initiatives and the Internet 2's pipe system. He's also involved in the IST-EG project, which is contributing to the grid environment. Then, second from the end there is Jiří Novotný from Masaryk University in the Czech Republic. Since 1993, he's worked with the Institute of Computer Science at Masaryk, and there he led the IP router development project that was the first to connect Masaryk University to the internet. Then from 1998 to 2000, he worked for TeraBeam, working on intelligent PCI communications cards. And he's now working on developing the combo series of PCI cards, which are based on FPGA technology, and that's also back in Brno. And then finally, we have Andrew Cormack of Ukerna. He's now Ukerna's chief security advisor, but he was previously the head of the Janet Cert for 3 years. He's also a member of the Permanent Stakeholders Group of the European Network and Information Security Agency. Okay, with that we move to some short presentations from each of the speakers. And so we start with Gianluca, and I will very quickly find his slides, if I can work out how to do it. Okay.
from there.
If you want to stand there, I'll do this.
Okay.
Okay, well,
It's the same version. Okay. Okay. So actually the question of the panel was about researcher openness and operator secrets, and so my discussion, the start discussion I want to do here is about how to actually build some a community-oriented measurement infrastructure. How do we actually get around it? How do we actually convince people to use it and other people to actually deploy in their own network? And well, the thing is very simple. I mean, first of all, we need to know what the trade-off is, and we need to. Okay, I'll go here. And that's very simple. The trade-off is always about value versus anxieties. So the value is the value for the operator, vendors, and the users. And the anxieties are usually the ones of the network operators. So what the network operator thinks about is that their activities every day are driven by process. So anything that is outside the process is seen as disruptive in the bad sense of that term, meaning that it could disrupt the network operations. But the thing is that the good thing there, they also understand what value means because they need to have value-added services to add to basically not being commoditized too soon. And we have this second actor in this that needs to participate in this community-oriented measurement infrastructure are the manufacturer, network equipment manufacturer. They won't get in, they won't do anything until they find that there is any value, and at that point they will realize soon that they cannot miss the train. So we need to show them value first, and then they will join happily after that. And finally, there is the network users. I mean, basically, the usual concern is about privacy. So this is the usual anxiety. But we notice in many other domains that privacy is a concern as long as basically there is no gain for giving out privacy. So users are happy giving away some of their privacy, some of privacy information, private information, as soon as they see that there is actually something that they gain in exchange. And in particular, there is a set of users that really don't care about privacy. There is corporate networks. Corporate networks, when you sign in a company, you give up your soul. You just say, okay, look into my emails, look into my packets, do whatever you want. And in that domain, basically, they really are interested in understanding what is a good network measurement infrastructure without caring about privacy too much. So how do we do it? How do we go about finding values? First of all, we need to support arbitrary traffic queries. So if you have a community-oriented measurement infrastructure, think about this. You have many systems out there that monitor packets, monitor traffic. What you want to do is that you want to compute anything on the traffic. You don't want to be restricted to do, for example, NetFlow analysis, or you want to be restricted to, well, before NetFlow was SNMP data. Done a lot of that as Sprint, and well, right now NetFlow is better. But the idea would be to do any query, and basically we can see infinite applications. We have seen many of them today about security, accounting, planning, capacity planning, and so on. Then what we want in this infrastructure is that we want multiple diverse environments to be working together and without having to modify our code to compute the traffic queries we are interested about. And this means we need to run high-speed links, we need to run wireless links, we need to also understand NetFlow feeds because they are everywhere. And finally, we want to have this infrastructure that is appropriate for fast prototyping. Think about Planet Lab. If you're familiar with the Planet Lab project that started at Intel, and then now it's a big number of systems out there, more than 300. I think there are close to 400 machines around the world. And researchers and users and even companies, some small enterprises or most startup are using Planet Lab just to prototype and to show to their own customers, look, there is this application that runs on hundreds of these nodes and it runs well, even though Planet Lab has its own limitations. And this is what we want in the community-oriented measurement infrastructure. When we get this, we get the value. Now the problem is that how do we find the value? So basically, how do we relax the people that actually need to get this thing? Yeah, these are not in sync. And because I have actually a reference added on the finding value. So first of all, well, the idea is that anonymization is the wrong solution. Anonymization is not what we need to look for. First of all, because it's never enough for data owners. I mean, network operators will always talk about we want appropriate anonymization, proper anonymization. And that means no data out. And the anonymization is always too much for data users. So it's never you're always hiding the information that the data user really wants. They think about security application, you think about running, for example, anonymization IP addresses, you're always hiding too much. And there is a good reference is actually, this problem has come up already for people running over weblogs. Basically, there was the same problem. Weblogs are private for companies, and how do we get actually, I don't know, Amazon or Google to give out the weblogs with the request to actually just characterize caching or design new systems for content distribution? And the notion was exactly the same. There is a nice panel at WWW 2002 where Jeff Mogul says exactly the same thing. Anonymization is not the right thing. What matters really is data ownership. So who owns the data? The idea is to say the monitoring system owns the data. No data can get out of it, just query results. So what we need to do is just have users that write queries, ship the source code to the system. The system runs the query with the operator watching what the source code is doing, and then the query results are available to whoever posts the query, while no packet data is ever shipped out of the system. And well, basically, the challenge is to automate all this. I think I'll stop here because I'm over time.
If there's any immediate questions there, but we can move on to Stuart.
Okay, coming from a slightly different direction, that's more in terms of the practicalities of what we can do with the networking we've got. If you like to press the button, move along a bit. So these are some of the questions we need to have a look at and we need to answer. So what do we want to monitor? The data, as in the content? Are we interested in the usage, the length of time data's around, who they are, the users themselves? So the first thing we need to understand is what is it we actually need to monitor? What is the reason for it? Why are we monitoring it? Are we monitoring it for performance reasons? Are we monitoring it for billing reasons? Lots of people want different things here. Where does the law stand on this? It's very interesting when you actually start digging in and you sit down with our friends in Brussels and talk to them about it. And where they stand depends on the answers to the two queries above. For some of the things above, they require monitoring. For some of the things above, they forbid monitoring. And this leaves us in a very interesting situation. We have the situation where, for example, they state that the lawful people, whoever they happen to be, and we can query that depending on which part of the world you're in, are allowed to monitor voice calls. So the police can come along and listen to what's being made on a voice call. They also state that they can't monitor personal information, like your credit card queries. But when everything's running on IP, how do we tell the difference? We are seeing packets. They are just lots of packets. They're all the same. I can't tell from a monitoring perspective very easily whether a piece of data wandering by happens to be a piece of voice or it's got somebody's credit card details in it. So we've got some interesting things there. And then we need to understand what can we monitor. So if we go over to the next slide, let's have a look at a few facts. I know what the guy said this morning in his little thing saying we got to 10 gig, a little bit out of date there because 40 gig links are already here. If you don't believe me, go next door, they're actually demonstrating them. 40 gig links are beginning to become deployable. If anybody's been following the next generation networking from BT, called the 21st Century Network, for which all the agreements were made about 2 months back, they are based on a 40 gig backbone. The first links will be deployed live in October. So 40 gig is here. Again, if you don't believe me, please go downstairs and have a look. The only reason they've taken as long as they have is economic conditions. Like any other manufacturer, we make what we can sell. If the service providers are saying to us, we've got overcapacity, they're not going to buy bigger pipes. So it's taken about 3 years before the market conditions have grown to the point when they're saying, we want bigger pipes. We had the 40 gig technology working about 3 years ago. 100 gig links are not very far away. If somebody said we want them today, we could deliver them, well, fairly quickly. We have them in the labs. 100 gig is already working. If you believe otherwise, knock on Cisco's door and we might show you. Now have a look at a few of these facts here. 40 gigabits is approximately a terabyte of data every 4 minutes. 100 gig is a terabyte of data every 1.5 minutes. Now, if you've got shares in EMC, I suggest you buy them very quickly, because the biggest disk drives they make today on a single drive are not a terabit in size, which means we're going to have something like 1 disk drive for every minute of data we're collecting. Does this make any sense? Of course it doesn't. We can't do that. So we have to already understand that we can't really store this data. Somebody asked this morning, they put their hand up and said, I think it was the Sprint or whatever it was, do they store that data? Well, I think that answers the question no. Because although Moore's law states that computing power goes up, what doubles every 1.5 years, or say 2, well, they don't seem to realise that in the world of networking, we don't bother with doubles. We tend to go up in values of 10. So every 3 to 4 years, we can go 10 times as fast. So we're outstripping the processing power, and even more importantly, we're outstripping the storage power. The only thing that's holding it back is economic requirements for that much bandwidth. Somebody also asked me earlier today about what did I think the technology was for getting into your house, because we're talking about videos and all the rest of it. I was in Norway 3 weeks ago where we were looking at an experimental 100 megabits to every house in the town. 100 megabits to every house. 70,000 houses, 100 megabits delivered to them. And all they do is they rate limit depending on what they want to buy. So if the customer says, I want 10 megabits, they'll rate limit to 10. If the customer says, I want 50 megabits, they can have 50 megabits. And if you've ever followed what goes in the Nordic countries, they tend to be about 5 years ahead of the rest of us in Europe. So we're not going to be long before houses are going to be running 100 megs, and probably 1 gigabit will be before the end of this decade. Just think of that kind of throughput. So even if we only capture the headers, it's absolutely impractical. I know these nice chip makers may be doing things to get around some of these problems, but today we don't actually have the technology to store this stuff anywhere. Because the middle bit there, we already have routers capable of switching in excess of a terabit a second. We have routers that can switch 1 terabit every second. So if I wanted to monitor everything that's going through that, what am I going to do with it? So we have to use other techniques. So if you just press over here. So we've got a few options here. One of the options that we're looking at very seriously, and we've implemented on our big routing boxes, is sampling techniques. We've been working with some of the universities in Europe to carry out various experiments and tests on what type of sampling, what kind of sampling rates, what we should be sampling to actually pull out useful information that gives us everything we need to know. But that depends on what we need to know, of course. But if you are interested in anything to do with traffic engineering, even to do with billing, sampling appears to be able to give us the right solutions, where we only have to look at maybe 1 packet in 100. And one of the big advantages, and one of the advantages that the regulators quite like on this, is it automatically gives you anonymity to all the data, because you're only seeing odd samples. And if you randomize the sampling, the information you get is always going to be anonymous, which is another big advantage. So if networks are necessary from hardware, we're going to need to invent some new technology. We know that ASICs currently are not fast enough. They're not flexible enough, even the ones we use. Well, the other problem we've got, and I mentioned earlier, is this legal intercept mechanism. It's posing us major problems. We've all rushed out there with voice over IP and video conferencing and all these other interesting things. All of a sudden, the regulators have started scratching their head and saying, how do you conform to this requirement for legal intercept? How does whoever the security bodies in your country, in the UK it's MI5, in America it's FBI or whatever, how do they actually do legal intercept? It's not too difficult if you are the owner of the source of the information, i.e. the company, but it's very difficult if you're a service provider who's carrying other service providers' data. You're getting thousands of terabytes of data come through your network, and the guy's saying to you, I want you to look for this little packet that's 60 bytes long. It's even worse than looking for a needle in a haystack. You need a very good magnet, just to show that. Just a few more thoughts. As I mentioned, sampling is good from an individual privacy point of view. The more sophisticated attacks are going to require more sophisticated monitoring mechanisms. We heard this morning. I threw in a question this morning. We're starting to see situations where there are protocols appearing that have port numbers that are not only dynamically assigned, but change continuously during the flow of the network. They call it port hopping. So the actual port number you use is 16705, and then the following packet says to it, the next one I want you to send me is on 30207. The next one I want you is 1726. So the ports move about all over the place, specifically so you can't sniff what's going on. So we have to deal with that as well. And one of the things that's worrying to the industry is, will the need for privacy lead to a change in network usage patterns? For example, will everybody use encrypted links? If they do, monitoring becomes nigh impossible. Okay, so that's the end of my little talk. I'll let this man go here. Some food for thought.
Okay, thank you. Okay, so then we move to Nicholas.
Shuffle ourselves well enough, Kevin won't have a clue who it is by the end of it.
Never mind. So I've tried to first give a small overview about what's happening within the research and educational network in Europe regarding opening access to their monitoring information. So there are various approaches taken by the different end-to-ends. You've got end-to-ends who are opening opening access to most of their data, link utilization, delay, whatever, with the exception of possibly the NetFlow type of data for most of the time privacy reasons. You've got other end-to-ends who don't show anything because they possibly don't have enough resources to set up public monitoring infrastructure which need to be continuously maintained and so on. Or some other mention that they don't want to open it for security reason because the less you show, the less likely you will be you will be attacked. So they don't want to have their monitoring infrastructure being used as a scoreboard for hackers. Kind of looks, there's a nice 1 gigabit links there. Let's try to generate some attacks and see, oh, it's coming green, yellow, now it's red. Gotcha. So that's something they potentially want to avoid. Some other don't want to end up with an overload of compliance or requests to their NOC. because the data are available to any user who possibly don't understand what's happening in the network, don't understand what's IP, and see, oh, this link is going down, and that was the one I was using, so start calling, oh, what's happening? The path has changed slightly. So that's something possibly they want to avoid. And the last reason is privacy issues. That's mostly concerning net flow or even access to a given institution. Let's say you've got two very good universities in the UK that I won't name, and with which there is quite some competition there. One could say, oh, why are we paying so much money and you are not using your link? So that's also a part of the, I'm not saying it's in the UK that's happening, it's another country, by the way. So there's the need from the operator to protect their customer to avoid a kind of fight like that between them. So those are roughly the kind of main reason I've heard for not opening access to the outside world. So coming from the other side, what does the researchers need, who are most of the time the people who want to have access to the monitoring information provided by the networks? So they want to do anomaly detection, and for that they wish to have raw net flow data with a little sampling and anonymization as possible, so they can run, they can analyze the data in any directions. The second main utilization I've heard of is traffic engineering. So they want to have access to history of the IGP and the BGP, so they can rerun them over topology and inject with traffic matrices they could build with NetFlow data, for example, AS2AS traffic matrices. And they also want to have access to the configuration currently being applied to the router, so they can even further refine their model for the traffic engineering, and the one also to have the network topology with the cost and so on. A third point, fairly close to the traffic engineering, is network modelization. When they're working on traffic engineering, testing new algorithm to optimize whatever it is, they want to use a modelization of the network as close as possible to what's happening. So they want to have real traffic matrices. They want to simulate as much as possible the real behavior of a network. So how often does a link fail? For how long? Have you got flapping? All that kind of information is of interest for them to allow them to further refine their model.
Modelization? Visualization.
Oh yeah, sorry about that.
I thought I was very much uninformed with the marketing
No, I think that's my keyboard who is not very well informed there. And the last point is active testing. So they would like to plug to our routers or switches some equipment to do active measurement or test new protocol and so on. So that's roughly what researchers, for what I have understood, would like to have from the existing network.
Are you talking about researchers inside the network, core network researchers, or researchers sitting in the connected institutions?
Researchers sitting in connected institution. So what should be the future of monitoring? So I've listed few points which I think may be of interest, and it's rather for the short term rather than on the long term. So I think the monitoring should help us to be more proactive rather than reactive. There are sometimes things happening in the network. Of course, we are not monitoring everything because there are so many things to be taken into account. And sometimes we realize that, oh, something was going wrong. We didn't detect it. Maybe if we were monitoring this bit, that would have prevented us to have this problem running for a few weeks. So by having some monitoring, we could have avoided that kind of situation. And from time to time, active monitoring can help because active monitoring gives you a kind of feel about what the user would experience. We don't want either to overload the network operators with information. Too much information kills the information typically. So a quick overview of what's happening in the network in a kind of single page would be of lots of help. Currently, we've got kind of simply Cricket, which is monitoring the link utilization of all our links. But to know what's happening, you need to go to all the Cricket interface to check the utilization of each link and check if nothing wrong is happening. And at the end of the day, it makes Cricket useless for checking on a daily basis what's happening in the network. You will only have access to it if somebody has mentioned to you, oh, there's a problem there. And then you will check, oh, yeah, obviously something wrong is happening or something different is happening there. And then I would also foresee the extension to the multi-domain. The IP packet doesn't stop at the boundaries of your network. And you only got vision to what's happening within your own network. And most of the time, it's not where it's happening. So if you could see what's happening a bit further, that may help you to reduce the time to troubleshoot a problem or to pinpoint where the problem is. Or maybe rule out simply the network. That's not the problem. The problem is not coming from the network, it's coming from the end site. And for people troubleshooting, a finer grain monitoring on selected flow where the problem has been spotted would also be of interest. And finally, when people are building new protocols and whatever, they should, I think, include their monitoring, which is currently being done, but as well way of troubleshooting what's happening, and not just kind of let the people try to find out, oh, what's happening there, something is wrong. And I leave it here.
Thank you, Nicholas. Okay, so we've heard a lot about the problems and a lot about the issues. So now we move to the man with all the solutions. And Irina Volny.
Maybe put my slides. Should be better.
Okay, so what's full screen in anybody know?
I guess you can. I use big font, so you can let it. Control L, I guess it's underlined.
Okay. Just need the full screen.
I'm not. I'm not sure if it's necessary. It's Control L in Linux. Try.
Sorry. I'm not familiar with it. Vidok?
Sorry, I tried that one. No, not here. I guess it's readable.
Okay, we can, manage.
We can leave it.
Okay, cancel the menu and then we'll try Control L. Try.
Okay.
There we are.
Oh, great.
Control L.
So fine. Next first slide. So I will start talk about some technical aspects, but it's a lot of things we listen today. All the day we talked about the technical aspects, so all of us know that the importance of network monitoring will grow up because we would like to know what's happened on the network. We would like to know about all accidents. We would like to prevent our networks, and it's the reason why we need to know what's happened on the networks. So right now we can use either a black box solution with high price, and unfortunately they are not flexible enough because users go, or developers, network developers go before the huge providers will be huge box providers. So the new solution, new network, new monitoring solutions are added later than they are necessary. So unfortunately, it's not a really flexible solution to use black boxes. We can use PC computers which are flexible enough, but on the other hand, they are not fast enough. They are fast enough for 100 megabit solution, say in some cases up 1 gigabit solution, but not faster. And situation will be even worse. The bandwidth of networks grows 3 times faster than computer power, so there is a huge gap. According Moore law, the computational power doubled every 18 months. According Gilder law, bandwidth grows every 2 times every 6 months. So there is gap. So there is no solution. Use just PC computers for flexible network monitoring without any hardware acceleration. Next slide, please. So we need to, for high-speed networks, we need to use some kind of hardware acceleration. We listen today that ASIC chips are not flexible enough because they are very expensive, and of course the demand for monitoring change very fastly. So if you use ASIC chips, you have some card or some box with ASIC chips, and you don't need to use it because it's new situation on the network, so it's not flexible. There is another techniques which comes to be used more and more using. It's programmable hardware. It's today there was a lot of presentation about FPGAs used on DEC or combo cards or SCMPI adapters, or some hardware accelerator using network processors like Intel card. Both there are two part of peoples. One of them say FPGAs are better. Second one say network processors are better. But it's still the same concept. It goes more and more parallel. Network processors are on halfway. FPGAs go much more parallel. So it's the changing in the hardware situation. And today we listen a lot about the SCMPI project, which developed a scalable solution up 10 gigabit with hardware acceleration. Its cards are based on the FPGA technique. So it's the situation. And today we also listen a lot about Lobster project, which followed the SCMPI project. So what I can see from lowest level of network monitoring, like hardware developer, new ways. So first, it's distributed systems. Today was presentation about Lobster. It's if we use more systems working together, we have new view on the network. We can get a new view. So it's going from one point to many points. Second way should be box, which is simple box. It's modular system. It's something like Lego system with pieces of hardware, firmware, which is a program for the hardware and software. We have a lot of building blocks, and we can put them together. The advantage of that system is that it could be done very simply way, or relatively simply way, but it needs a very experienced administrator. So if you know what you want to monitor, what you want to put together, you can use such approach. You can use equipment with a lot of building blocks. You put them together and you can measure it. And it's relatively simply and relatively cheap way. The second is opposite. It's a really complex device supporting wide range of complex applications. So we have many applications sitting in one box, and we can use application for monitoring for the purpose we need. So that device is complicated, but don't need such experienced administrator. And that approach need to have a very good GUI or a very good configuration management, because it's too complex. So people working with router know how it's complex to how complex is to configure router. It's even worse. So we need a really powerful GUI or really powerful tools for configuring such device. Next, it's a self-learning devices. Tomorrow, in a first session, was saying something that we need very fast. We find an incident on the network, and we need to very fast to remove it or block the accident. So right now, according Evangelos' presentation, we know that in several minutes can be virus spread around the globe. So we have several minutes to make some changes and block that things. So it's I guess it's not any human. There is no human which can do that. It's really fast. So we need some kind of learning devices which has big database, which has a lot of knowledge about the behavior of the network and can prevent network very fast. Unfortunately, it would be really nice, but still we are on the beginning of that process to have such devices. One of that things could be, for example, design on either DAC or combo cards. Could be we can use the card for the network monitoring, and if the card has more ports, we can send suspicious packets to other ports. So we use it like splitter, intelligent splitter. We use card first for network monitoring, and if there is something suspicious, we can send it to other port. And on other port, we can have farm of honeypots or servers. We can slow down. We can do some traffic shaping. We can slow down with the suspicious packets, and we can analyze them. Even more, we can use it like honeypots. So we can try to play game with the intruders. We can do that. So and right now we have boards which are able to do that. I'm sure both combo and DEC cards, or Scampi adapters, which is based on combo cards, are able to do that. We just need card with packet classification. Both card has that, and we need more ports on the cards. So that is here. And it's situations that we need to move from network monitoring to prevention, to network prevention. So. And last slide, I talked about the technical aspects, but there are some other aspects. I guess it's maybe more important than technical aspects, because today we talked about many technical solutions. We know that pieces of building, bricks for building, for network monitoring are there. We can put them together. We can have a small house, bigger house, whatever, but we can do it together. But do we really want to have big amount, very inexpensive equipment or solution for near everybody? Do we want to help hackers? Do we want to help them to develop more sophisticated attacks using new solution? I guess no. But it's here. It's the life. What about our privacy? It's all guys talking before me say privacy. I guess we lost it. But it's not just internet. All of you have a cell phone in your pocket, and you can be really simply tracked in your ways. So your network operator knows where are you every day, every minute. So it's not just internet, but cell phones. Did we open new Pandora box? Yes, we did. It's a pity, but we did. And if we don't do that, anybody do that. So anybody else do that. So there is no way how to. And Will we need to change lifestyle for more privacy? I guess yes. If you don't care if anybody's snooping you, if you don't care that you have every day a lot of junk mails in your email and in your S-mail box and whatever, we probably will need to do something. But I don't know what we could do. So thank you for mentioning.
Well, I guess the obvious thing is to throw away our telephones and computers, but I guess then we'd all be out of jobs. Okay, so the final presenter is Andrew.
I can't even work out how the clip works. Oh, it's that way, right. It's a bit strange to express Yep. Oh, okay. Seems a bit strange to me to be concerned that our network managers might know where we are when we're on a video stream. Hi, guys. Yeah, I've been asked to talk about user privacy, or maybe I volunteered to talk about user privacy, because actually nowadays I think I am a user. I think I always was. I'm getting no noise. Is that because I've got the microphone beautifully set, or because it's not working? Yep, I'm audible. Right, good. The jacket is rentable for a small fee. Actually, user privacy was a concern back in the days when I was a sysadmin. I used to have the root password to a university's web cache, file server, and mail store. You know, I could really mess up people's privacy, and that used to worry me. Okay. Actually, the other thing that Kevin didn't mention is that nowadays I'm also a law student. Only a student, remember. But looking at the law, I'm actually starting to find some guidelines that get me out of my old concern as a sysadmin of what can I do, what shouldn't I do. Quick mention of the two major European laws that apply. If you want to know more about this, I'm doing a full presentation tomorrow morning. There's the European Convention on Human Rights, particularly Article 8, and there are two data protection directives, 95/46 and 2002/58. If you type those into Europa, you will get the wonderful documents that you're looking for. Those have pages and pages of detail, but the key principles are any interference with privacy has to have a clear purpose. It has to be proportionate, which actually Gianluca summed up beautifully, which is users will give away their privacy if there is a benefit. That's proportionality. Is the benefit greater than the loss of privacy? Thank you. This morning's speaker said that in the States you can buy a password for a £3 voucher for Starbucks. I believe the test in the UK, as far as I remember, was a cheap biro, and they were getting passwords at a similar rate. So the Americans have a higher price on their privacy than we do, obviously. You need to be open about what you're doing. There needs to be openness, what data you're collecting, what you're using it for. Partly by law, but partly it's good practice anyway. And actually, since the bad guys are doing social engineering, I want to do social engineering too. And if I publish what data I'm collecting, what I can use it for, no, you're not as anonymous as you think you are, maybe that'll put off some of the, possibly the less malicious, but at least some of the misguided students on our networks. And there need to be controls. So there need to be controls to ensure that the information that is collected, the privacy breaches that occur, are only used for what you've said they're used for. So you need to be very careful if you're passing information on. The moment the thought comes into your mind, hey, I'm logging this for that, I could also use it for that, stop and think very carefully, should I do that? The law is useful. It's a useful guide, I think, to best practice. It also has teeth. There are some activities that are just banned by law, but they're the sort of activities that if you do them, your users will hate you and will go off to other providers anyway. If you start trampling all over people's privacy, they will get upset. If you're doing worse things than they will buy for a $3 Starbucks voucher, they will complain. And certainly all of us on academic networks, our reputation is actually hugely important. And if word gets out that we are messing up with users' privacy, then our reputation will go down the tubes very quickly. A little bit more detail on the law, which just to run through quickly. Life is much easier from a privacy point of view and therefore from a legal point of view if all you are looking at is headers, because the network has to look at headers anyway. It's like the address on the outside of an envelope. I can't really get upset if the post office read the address on the outside of the envelope. Actually, in the UK, it would be nice if they did it more often. I can get upset if they open the envelope and start looking inside. That's a very different order of intrusion. If you can anonymize data, it's better. Remember my proportionality. It's a balance, so that the less intrusion into privacy, the less you need to justify it. Not saying anonymize every time. There may be good reasons for not anonymizing. Header data tends in law to be protected by those 2 European Commission directives, which are extremely precise and extremely detailed. So you'll find almost certainly that all 25 member states will have very similar law on dealing with headers. So if you're an international network, Dante is the prime example, you probably have less headaches if you're dealing with headers, with flow data, with aggregate stuff derived from headers. Conversely, content, the stuff that the network doesn't need, you really need to be very careful. Only look at that if you have to, because it's very intrusive into privacy. It's perceived as very intrusive. You're likely to be heavily restricted by law. The European Convention on Human Rights, Article 8, is 2 lines of text. It's extremely non-detailed, it's extremely non-specific, and every country has wildly different implementations of it. They're all compliant with it, but they're very different. And if you're trying to work out, because you want to intercept content in 25 different member states, you have to read 25 different laws and make sure that you comply with all of them. And I've not looked at it in detail. I think that might be impossible. So stick with headers if you can at all. If you're doing any activity, whether it's doing research, whether it's running a network, think, why am I doing this? Again, I think one of the previous speakers mentioned this sort of thing. Know why you're doing it, and then you know what law will apply, and usually you will find if you are trying to do something reasonable, I just want to run the network. I need to do this to make the network work. Fine, says the law. Go do it. Fine, says your customer. They want you to run the network too. Is the risk if you don't do it greater than the harm if you do? Can you do it in a less harmful way? Anonymization, getting computers, getting the hardware to scan the content of packet rather than revealing it to human eyeballs. Once you're clear on that, you can probably look at your national law and say, am I allowed to do this for that reason? And the third factor that I don't think was mentioned is also some laws distinguish between who is doing whatever it is. So who is doing it, why are they doing it, and what are they looking at? How long do you need to keep the data for? If you only need it for 5 minutes, only keep it for 5 minutes. It saves you all those expensive terabytes of disk. And it also keeps you on the right side of the law, which is good. How am I going to protect the data and the user? Don't just think of people as users. Think of organizations. You really don't want people publishing traffic statistics. Now, if one of your users has a very different pattern of traffic, different pattern of protocols coming out from all your other users, it's not personal data, but it could probably be quite damaging, either to one or the others. They'll both get beaten up. Why aren't you like them? And do you need to inform the user? It's probably a good idea anyway. In some cases, you might need to get consent from the user, particularly if you're doing very intrusive things. If you know the answers to all of those, and if they're answers that you can sleep at night knowing them, then your customers are probably happy with you, and the lawyers are probably happy with you as well. Thank you.
Thank you, Andrew. Okay, well, that's given a lot of food for thought. And we still have plenty of time for questions. So are there any questions that you'd like to put to the panel, or alternatively, are there any questions that the panelists would like to ask each other?
It's a bit inbred, isn't it?
Okay, someone...
we've been talking about anonymization for much of the day today, and I just wanted to know what people really mean when they say anonymization. For me, it meant what Andrew just said, which is that you can look at the headers but not at the content. But are we all agreed on that's what it is, or that's also debatable?
I think that's certainly debatable in some of the places I go.
Sorry, just a sec.
We need to take the context slightly larger than the European Union, because although I'm sure most of us do come from the EU, we need to be in a position to understand that as soon as we cross international borders, we may be in a different position. So in the days when we had telephony, we had extremely well-defined borders. There was a protocol called X75 that did the signalling between the UK and France and Belgium and anywhere else. So everybody knew what was going on, and they were restricted in information that could be passed from one side to the other. The problem with the headers is it is not anonymous enough for a lot of places. It still says who did what. Even if you don't know what they did, you still know who it was and you know where they went to. So you have to be careful that the EU may say that that's okay, but you still need to go further than that for statistics you're publishing outside of your own organisation. They must be anonymised to the point when you cannot determine who sent to whom. Even if you can't see the contents, you still need to be able to stop. In the same way, then we go back to our letters, our man talked about the postman, there are very strict laws in what the man who delivers a letter to your letterbox can disclose. The post office in any country in the EU cannot send out statistics that says Stuart sent letters to Argos, the catalogue company, and bought something. We don't know what he bought, but he sent a letter to them. They're not allowed to do that. The postman is not allowed to actually give any information about what letters he gave to your next door neighbour. So again, anonymisation has to include the headers as well, from my opinion, from what I've seen, unless anybody else thinks otherwise.
No, I don't think there is anonymised data and unanonymised data. There is more anonymised and less. I think this is live. Yeah. The key thing is not to give out any more information than you have to. Simply looking at headers, you'll hear some people say net flow data is fine. There's no issues with net flow data. Suppose I find when I'm looking at my net flow that a professor's desktop PC has created a large number of net flows to a cancer support site. That is potentially very damaging data. But it's only headers, it's only net flow. No, it's personally damaging data. So anonymization is a tool to achieve the reduction of intrusion into privacy. Try and get people to be clear about what they want the data for, how much anonymization can I do, how little data do you actually need to achieve what you want to do.
Okay, over at the back there.
Mike Norris is my name from HEAnet.
De-anonymized himself.
Mike Norris, HEAnet, is that?
Yes.
I just have a few very brief comments. First of all, Giancarlo, I think, omitted from his list of interested parties the computer equipment manufacturers. He listed the routing equipment manufacturers, but I think in the internet, particularly these days, and there's a sign downstairs which says the computer is the network, or maybe it's the other way around. It's some silly anodyne equation like that, because nowadays the computer that people buy is the essential part of the network, and I think until the manufacturers of the PC had a real interest in things like security issues and so on, nothing is going to happen. because they have the biggest stake in it. They have one of the major stakes in it, and until if people are going to be turned off by pornography and spam and DOS attacks and so on, they're going to be the big losers. The second thing is that Nicola was talking about reasons why there shouldn't be open access. I'd like to sort of spin it around and put down the reasons why we should have open access, particularly in the NREN community. I think we should start from the position, and I'm not saying this to be on the high moral ground, we should by default assume that we should publish information. We should make available as much as possible within reason, because most of our activities are publicly funded, and our users and the community in general is entitled to see that. And the reason I say that is not to be holier than thou, but it's for practical reasons. If we do get queries from the public or from the press or anyone like that, we can point them at a website rather than having to compile large amounts of statistics. So it's in our own interest to be as open as possible, and I know, Géant does this, and they anonymize it by country, which is great. They can say how much traffic goes from one country to another. And I suspect that it's not a reason, but I think it could be a pretext for some NRENs or for some institutions not to disclose monitoring information because they might be embarrassed by the underuse of the resource, which is publicly funded, remember. So I'm in favor of making as much of this known as possible, because we are, after all, education and research. We should be interested in truth and all of these things. But more than anything else, I want a quiet life. I want to be able to point to information that's there rather than have to compile it every time a query comes in. And finally, a question about, there was a good suggestion there about every new protocol being accompanied by a monitoring requirement. Agreed. But we still have providers claiming to support protocols and not monitoring them. We still have equipment being sold which supports IPv6, support in inverted commas, but doesn't measure it. And this is becoming very serious now. And it's all in the interest of producing the equipment and selling it, but it's incomplete. So I certainly support that suggestion. I don't think anything should be sold until support means supporting monitoring as well as delivering or switching or forwarding the packets. Thank you.
Okay, well, who wants to start with the first response?
Apart from the computer is a network, which actually I think comes from Sun, so I don't comment on that. But the discussion about what actually the end user, the computer user, is interested in, is that is actually one of the main reasons why we, as Intel Research, we got involved into network monitoring, because what you want to have is that your laptop is not infected by worms, is not infected by stuff coming from the network and runs maybe a spam filter directly in the hardware. Now, how do you actually do that is really a question we have no clue how to answer, because we don't know how to do that when we have a network operator that actually knows a lot more than the network, knows a lot more of what it is interesting to look into the network. So that's why the network monitoring for the future of network monitoring is, for us, it's really to look into what additional features are needed for network monitoring. And that is actually coming from other comments about what NRANs are, or users are interested in today. Well, that is not a given that there will be interested in that tomorrow. So we need to find ways to support whatever they ask. And then the second question is about, so there was the comment about the high speed. So now we go to 40 gig. And the future of network monitoring needs to move to the higher speeds. Actually, we need to first understand how to do network monitoring in very low speeds, because today, if you think about distributed anomaly detection schemes, well, there is nothing. There is nothing out there to run to any speed. So there is no one that has done it unless other than just centralizing all the data in one spot and then computing there. So we need to understand how to do it, and that's where the end goal would be actually to deploy monitoring functionalities directly into each individual NIC card, so that you can customize its own, so that you can tell, well, I don't want to see this traffic because I know that it's gonna be good for me. And I think that is where the privacy requirements of users may go away. Basically, well, having some hardware that looks into everything you look, because anyway we're gonna look into it because the CPU is doing it. So we do it first outside your machine, and then we move inside. At that point, we solve the privacy issue.
I have one comment about your next sentence, that new routers should be better equipped with monitoring. I guess I'm not sure if it's way. Me personally prefer solutions that I have very good router which do routing, and I have another equipment from another vendor which do monitoring good way. And in that case, I can make decision what routing machine fabric I can buy and what monitoring. So I guess I am not sure if it should be one box. I agree with you that routers can offer more monitoring solutions, but I'm not sure if it will be just one box.
I'll add a little bit to the last comment there. From a manufacturing point of view, and it's a very sad comment, is monitoring does not sell boxes. If we spend another $1 billion in research to build in all the monitoring we need for a 40 gig link, it probably sells us 2 more boxes. And the other comment that comes backwards is part of this problem and emanates from the research establishments themselves. All of you guys in this room and us down the front here are interested in monitoring, else we probably wouldn't be sitting in here. But if you talk to your colleagues at large, they are extremely interested in making the light go faster around the corner, curl around, do all sorts of clever things. But if you say to them, how do you know what it's doing? They don't see any use in that. So they'll invent a new technology to run at 100 gigs and do all sorts of clever things. You know, go both ways down a single piece of fibre, and they can see they're going to sell that. But when it comes to actually developing the tools that go around that, the monitoring and the provisioning and all the other things, that comes a long way down their list of interesting things to do. And we have this as a real problem throughout the whole industry, that if you buy a new washing machine, whatever it is, any piece of equipment you buy, it's the latest and greatest speeds and feeds. It's not whether the steering wheel feels comfortable and it's nice and squashy and it smells nice. And the same problem we have with the monitoring is that we're always pushing the boundaries of what we can achieve as a saleable box, and all the rest of it that comes with it comes in long, long later. It's never on the issue right at the beginning. I see it every day, technical specifications that says, we're going to build a new router. Here's all the specifications. When I get to line 492, it mentions management, if you're lucky. It's probably dropped off the bottom because they cut it at 400. It's like a golf corner. And we have to fight to get it back in again. And whenever I talk to our product people, they say, well, it doesn't sell the box. We'd only sell 2 more. And a lot of it is partly to do with the fact that people say we want the monitoring outside. But we have to get more pressure back from the outside that says, we're not going to buy your box because we can't monitor it. But we rarely hear that. It's a very difficult one to get around, is that users have completely different thoughts of why they buy things than we do here in this room.
Okay.
I'm not sure if things are different in Ireland, but I wish life was as simple as we'll publish everything and nobody will bother us. I think if you publish all the stats, you will merely get queries from all the other sites, Half of them saying, why did you tell the world about us and them so they could beat us up for making less efficient use of the network? And the other half complaining, saying, why did you tell them about us so they can beat us up for making more efficient use of the network? So I think you'll merely transfer the complaints that you get. Sorry. It's unfair.
I think we haven't found that. Maybe 10 years ago, there was some concern about that, but there isn't now. And I think one of the reasons is that we now have a Freedom of Information Act, and if people can't get the information from our website, they can get it some other way. It might be a more tortuous way of getting it, but they can get it. And I think our institutions subconsciously or otherwise have recognized that and now err on the side of being open with the information.
Our Freedom of Information Act has only applied to higher education institutions for about 6 months, so they're still learning.
Additional comment. Here I was presenting why the networks don't want to show the data, which are the reasons, which doesn't mean that I'm in favor of their argumentation. Obviously not. But I should possibly have needed to add a few points about why, what it is useful for. And one of the obvious reasons would be for troubleshooting. Okay, I'm mentioning it again. Sorry about that, but I think it's really useful for the end-to-end and fasten the whole troubleshooting process for the NOCs. And possibly we should be a bit more innovative in the way we would wish to present the data to the user. Not too technical, high level, and comprehensive for them. And that's something which is definitely not very easy to do, because we are techies, we are looking at the raw information, and we don't think about trying to abstract it and put it at a user understandable level. And that's something we should possibly try to target when opening the data to the users. That would give them a better feel of ownership of the service and of the network they are paying for, and that would be really great for them. And we have had also lots of requests from people mentioning, look, I want to do a video conferencing between this university and that university, but I don't know if I will have enough bandwidth. Just simple question as those one need to be answered for the people trying to set up data transfer or video conferencing. And that's a question I'm hearing every month, typically. Where can I get this information?
Our network, you can go to the site, anyone can go to it, it's quite public, and all of the video conferencing suites in all of our institutions are available via smoke ping. So you can see the trip times, the latency variation, and packet loss to all of those sites. But that's only half the story, of course.
Okay, so are there any other questions?
Can you hear me? Yeah. It's about the Pandora's box statement by Jiri. That was very interesting. We heard today a couple of times about using encryption. There are ways to anonymize your source address for using, for instance, a Tor network, multi-level proxies. Have we opened a Pandora's box in that it's we can do all this monitoring, or will people who want to sneak out under the radar be able to, and can you only monitor the stuff that's not really that interesting? So is it really a Pandora's box? I think I can get my privacy up there if I want.
I guess it's a Pandora box because it's the same like the hackers start work on the networks several years ago. So there was possibility to do something wrong on the network, so people use it, and we developed technique like to avoid it. So from other side, if some people try to use monitoring for their purpose, in illegal purpose, or our equipment, so we find solution. You talked about encryption. I know about the wire speed encryption cards, so it's doable on the same hardware we have.
Wire speed decryption?
Wire speed encryption and decryption, but not you can encrypt and decrypt, but not in real time to make introduction.
Okay.
So. You know, right now 10 gigabit encryption card would be very expensive, and it need a lot of hardware power.
Yes, but you see that a lot of applications, so either they are malicious and their users aren't per se, like some P2P programs are surely encrypted because they can be used to do unlawful things, or users themselves have malicious needs. And you can just switch on encryption on so much traffic that you're never going to catch it. And as applications move more and more towards encryption, towards port hopping, I don't know what, anonymous IP spoofing, you can probably, I think you will see an increase in this, which makes network monitoring of the traffic you want to monitor, like the white area that we didn't know 4 years ago. Actually harder than it was 4 years ago, instead of the other way around.
You can saw in the next 5 years ago, people used FTP, telnet services. Right now, all of us use SSH and SCP, which is encrypted, and I guess all traffic move that way. So.
So I'm thinking out loud here, but I wonder if it actually separates the issue of threats to the network, which you can monitor in the core, and threats to the end systems, which you can't because they're so obfuscated. I'm not sure how practical it is, but I suspect the ultimate encryption tool is IPv6, because in v6, I think, I'd be delighted to be proved wrong, but I think you can actually shuffle around the headers to the extent that even the port number is encrypted. I think you can send the source and destination addresses as the only thing that's in plain text, and the next header is the encryption header.
And we haven't even looked at IPv6 yet.
You may not have, but the bad guys have, and are using it. IPv6 is now being used to create backdoors. You break in with IPv4 and you create an IPv6 backdoor, because an awful lot of firewalls pass IPv6 without thinking about it.
All right, thank you.
I did say encourage you to sleep well at night, didn't I?
Maybe one more comment. If you encrypt your data, you probably are not intruder, because it's very hard to have a worm which is encrypted, because you need the exploit maybe, but you need cooperation from the end box, and the end box has to know key for the decryption.
That's the exploit.
Yeah.
All the traffic of the worm itself can be encrypted, and you can use anonymous source addresses. So there's only a small bit of exploit.
Oh, sorry.
Not interesting. And anyway.
Could you repeat? Please.
Sorry. As I said, the exploit code, of course, has to be plain text to work, but that's relatively trivial and small. It's the worm traffic itself that can be encrypted and can fake being like HTTP traffic, for instance. That's another option that we haven't discussed so far. And it can still spoof its source address, or not even spoof, but use anonymization techniques, so that the only thing you know is how to exploit, for instance, an RPC opening, and we know that. That's not really the thing we're looking for. I think it's getting harder, not easier. That's simply my remark.
Yeah, I mean, I think you were you nearly got there when you said HTTP, and that it needs the cooperation of the end system. Suppose the end system is a web server. The end system will cooperate by encrypting everything. Just send the exploit to port 443 rather than port 80. I think, and sort of developing what I said, I think it pushes the security perimeter to be much closer to the target. If you're worried about DOS attacks, you monitor for DOS attacks on the network, whether it's encrypted or not. Now, you know what a DOS attack looks like. If you're interested in attacks on email viruses, I have been keeping an eye on my laptop to see what was coming in. If you're interested in email viruses, you probably need to get down to the email client and wrap the security perimeter around there. That's not the way security has gone. You know, we've tried to make perimeters bigger, but with us wandering around with wireless networks, increasing mobility, increasing demands from users to do everything, it becomes very, very hard to push a firewall, to push a perimeter, actually any distance from the target, because there are ways. The further the perimeter is from the target, the more opportunities there are for an attack to convert itself, to get through the perimeter in one way, looking non-hostile. I mean, the SSL example is the classic. It comes in looking like HTTP encrypted over SSL. All it has to do is persuade the web server to decrypt, unwrap. It's got through the perimeter. There's more and more intelligence between the perimeter and the target, which can be subverted to convert the attack into something unpleasant. So I think that's the way the model is going, I think.
Absolutely. It's like with malicious traffic originating from client PCs, it's very hard to track in the network, while it is quite easy with users' assistance on this computer. Okay, thanks.
Or even without, if you're at the end site. One of the most effective ways to spot infected machines is simply to look at net flow, take number of packets exported minus number of packets imported. And you should know all the machines on your network that are net exporters of bytes. They are things like your web server. Your mail server is probably about 50-50. Your web server will be a net exporter. Your FTP server will be a net exporter. There's not many other machines that are. And if you look for the net exporters on your network and you don't know what they are, go and have a look. Very effective. You can encrypt all you like. The only way you can avoid that is to actually start generating chaffing, generating random traffic, to try and mess up the traffic patterns. But then you should start appearing on the radar simply because of traffic volume. I don't know what it is, but it's glowing bright on my graph. So.
Okay, at the back.
I have the microphone. Is it on? Right. It seems to me that whatever happens, we have to do intrusion detection, or at least monitoring at layer 7, because, well, if we believe in the OSI model for a second, because anywhere else is just breaking that. So that means, I think, either we do it at the client or we put some sort of proxy in. This has been done in the past. Do you think this is what's going to happen again?
Regarding the proxies and this stuff, I mean, you think about the corporate network settings, the traffic is very, very much controlled compared to anything else. So, I mean, if you move, and we always think of corporate network as small networks. Actually, well, they definitely are not, and they're not fast, but they're quite big. If you think of corporations like Cisco or Intel, they have large number of people in the corporate network that are entirely they're spread across the world, and they, well, for example, that's why there is an interest there. I mean, think about Intel, 80,000 employees. They all have a laptop. They all can connect to the private network, and the entire bandwidth that we get outside to the outside world is almost 2 gigabits. So we can monitor everything into the Intel corporate network, because you usually don't need to talk too much to the outside world. And regarding instead the comment about the net exporter, there is a problem then when the corporate network, you think about you have a boundary, security boundary at your network, then inside you don't look too much, and you allow applications like net meeting that are, for example, very difficult to figure out who's doing net meeting because they just build a peer-to-peer network inside the corporate. So proxies, yes, are used in corporate network. In corporate network, you don't have a security problem. You don't have the encryption problem because, well, that's easy to stop. And you can... Sorry? We don't have encryption traffic in the corporate network. Well, you don't have any traffic that you care about in the corporate network because it doesn't go out.
Are you sure? It's 80,000 people and you're looking for the one malicious idiot who's sending out encrypted HTTP tunnel steganography.
Oh, that is, so the way to do this kind of stuff, you basically need to build a tunnel through your own proxy. So okay, that you can do, but it's easy to stop because that's easy. That's the easiest thing to stop. Yes, because that is the place you monitor. So the proxy is easy to monitor because it's low link. You can see every packet, and there is a big firewall that actually does look at every single byte because there is no privacy concern, there is no speed limitation, and that's easy. Yes, and you can do that unless you don't care about that, and that's actually probably the case, but you often do.
Could you use the microphone? Yeah, sorry, it's a little bit difficult. We can try and use it.
I said I forgot about the mic. I'm not trying to offend you in any way, but I used to be responsible for a similar problem with another similarly large international corporation. And it's really easy to inspect whether HTML is legal, but it's really hard to inspect whether it's illegal.
Yeah.
Either you're very restrictive about the kind of HTML a user is allowed to see, but that generates a truckload of support calls, or you acknowledge to the fact that you can't really, if somebody really wants to get that data out, and I'm talking corporate espionage, for instance. I know I might sound paranoid, but it does happen.
Oh, yeah.
And he takes the trouble of actually steganographying this into, and there's good packages available to do that.
Oh, but this is not part of the Pandora box. We have not opened anything. That existed before having, I mean, you can steal my laptop and you get a lot of corporate information and it's easier.
That too.
And you
That's
can
your laptop?
So there.
Oh, okay, pity.
And the other thing you can do is actually, one of the main problems they have is that the phone calls to people that ask, and they just ask for the password.
Yeah,
and
exactly.
that's the main problem. So these are, we are talking about, I mean, are we going to have more complex problems? Well, figuring out, stopping people from stealing stuff, it's more difficult than monitoring packets. So.
What you mean? I was thinking a few questions ago, I was thinking the same thing. It basically boils down to the question, why are you monitoring? Me as sitting, I'm Guido, Abend, SurfNet, so the reason why I'm interested in monitoring is because I have to do my due diligence. I have to show that I wasn't completely ignorant. Actually, if all my users start encrypting their traffic, I would be a very happy man. I can just acknowledge to the fact that, yes, I've been shuffling encrypted packets back and forth, but nobody was actually doing a DDoS. I can still monitor the fact that they're not misusing my part of the network. And by doing so, I've done my due diligence, and I've pushed the security and boundary problem to the actual stakeholders, which would be the end users or the end institutions. I really don't want to see what's in the packet. I would prefer that I could show that I was unable to actually inspect the packet. Would be perfect. But the other question, the question that you were, well, actually the use case that you were discussing about what should an end user, so the people who are actually entitled to see the content of the packet, well, entitled, Andrew might think different about this, but have an ability to actually inspect the packet, that's another monitoring question. And I was very much triggered by the fact that you said that you were very sure about what you had in your network, because I'm...
Okay, we must cut in here because time is up. But I mean, if you want to respond very quickly.
I totally agree. I mean, you can know all the traffic you care about, and encrypted, you just know that it's encrypted. If that is all you care about, that's always good, and that's true.
Okay. Okay, I'm sorry that we've had to cut in the middle of that discussion, but to say that it's the last session of the day, the buses are no doubt waiting, and I'm sure you don't all want to walk back to your hotels. That brings us to the end of the session. I'd like to thank all of the panelists who contributed to quite a lively debate. Now, just remind you that if you are going, there's 2 BOFs this evening, starting at 6 o'clock. If you're going to those, but
That's in 27 minutes.